Solubility electrolyte practice. What you'll be doing is filling in this data table with the information just like the example that's shown here. So you are going to determine the chemical formula of the substance first, determine its solubility in water, if it is soluble or insoluble, then if it forms any ions, and if it's an electrolyte or non-electrolyte. Up here it says if the substance is insoluble, you're going to write none for what ions are formed. If something is soluble, that means it will break up into its ions in solution. However, if something is insoluble, it does not break apart in solution. It will not form ions, and so you're just going to write the word none here if that's the case, if it's insoluble. So right here we have sodium chloride, NaCl. Now we come up with NaCl from sodium chloride because I can look up sodium on my periodic table, and I know sodium is Na. It's in group 1, so it has a +1 charge. Chlorine is in group 17, so it has a -1 charge. So since this has a +1 and this has a -1 charge, they already cancel out to 0, and I just write NaCl. However, that's not always going to be the case. If I had put calcium chloride here, calcium would be in group 2 with a +2 charge. If I had a +2 and a -1, I would have had to cross over those two charges like we've done in other packets in the past to get my subscripts for my solution, or excuse me, for my substance. So here I just have NaCl because it was a +1, -1, and they already cancel out to 0. To figure out if it's soluble or not, you're going to look at this chart down here at the bottom. And in our case, we were looking at sodium chloride, which is NaCl. Here's chloride, Cl. It says that chlorides are soluble except for these. So if my substance had been AgCl, or Hg2Cl2, or PbCl2, then this would have been insoluble because it's an exception to this rule. So for these three, nitrate, chloride, and sulfate, they are soluble unless they're one of these exceptions. For carbonate, hydroxide, and sulfide, they are all insoluble. They don't dissolve unless they're one of these. And you can see group 1 elements or group 2 elements means anything in group 1 or anything in group 2, depending on what you're looking at. So because it is not one of the exceptions, it means that this chloride, NaCl, is soluble. So I put soluble here. Because it is soluble, I'm going to break it up into its individual ions. Remember we said Na was a +1. I can put a plus here to indicate +1. However, if it had been +2, I would have need to have written that 2, +2. So Cl is a -1. I can either write just the negative sign or I can write -1. If something is soluble in water and breaks up into ions, it is an electrolyte. An electrolyte just means it's a substance that dissolves in water, adding these positive and negative charges that allow the water to conduct electricity. See how electrolyte looks a lot like electricity? Because an electrolyte allows water to conduct electricity. So for each of these, do the same thing. Make your compound here, your chemical formula, using the different parts of it you may need to use. For some of these, you're going to need to use your polyatomic ion chart to figure out the charges and the composition of your compound. Figure out the charges, cross them over if need be to make your chemical formula. Then look on your chart down here to determine if it's soluble or insoluble. If it's soluble, break it apart back into its ions and call it an electrolyte. If it's not soluble, if it's insoluble, put none for the ions formed and put non-electrolyte here because it won't break apart to allow electricity to flow. If you do still have any questions on this worksheet, please come ask.